I'm very excited today to announce and let everyone know about our new ARM Cortex-M0 Plus MCU portfolio, or better known as MSP-M0 microcontrollers. Okay, so today's agenda will be talking about the portfolio introduction and features, and I'll be diving into specifics for the L series and the G series, and then how to just get started. Okay, so for our MSP-M0 MCUs, we really wanted to have three key pillars that really showcase our portfolio, which is cost-optimized, scalability, and simple to use. So our devices include availability and variety of speeds, memory sizes, pin counts, and integrated analog options. So in our portfolio today, we have the 32 megahertz family, which is our L series, and our 80 megahertz family, which is G series, and devices that are coming from 8 kilobytes to 128 kilobytes of flash, with 16 to 64 pins. And what's also really exciting is that these are pin-to-pin compatible across the different memory variants. So for example, if a customer would like to use a 128 KB part and want to go down to 32 KB or 64 KB in that specific package variant, you're able to do so. Also, our temperature ranges cover from -40 to 105 degrees Celsius and to extended to 125 degrees Celsius, and also coming to our AEC Q100 automotive options as well. So our team has worked really hard getting feedback from customers and sales teams and field teams how to make this simple and easy to use. So we have many different tools that I'll dive into today as well, on graphical device configuration with code generation, having code size optimized drivers, and honestly just plug and play subsystems, reference designs, and code examples so that you can quickly incorporate MSP-M0 into your product and ultimately accelerate your time into market. So with that being said, MSP-M0 MCUs really are providing customers and designers and engineers more options and unlimited possibilities. So kind of diving into our core pillars on exactly, what is their compute, our memory, package, sensing, control, and connecting of what are the key peripherals and key care abouts that engineers and designers have. So as mentioned, all of our MSP-M0 devices itself have this ARM Cortex-M0 Plus CPU, and we have available speeds from 32 to 80 megahertz that are less than 96 microamps megahertz as well. And we also have a math accelerator, which I'll dive in a little bit deeper in our M0G series, which can give you optional math operations such as division, square root, trigonometry, and other operands there. As well as we have a very small footprint packages from SOT, VSOP, QFN, and QFP from 16 to 64 pins with pin-to-pin compatibility. And kind of providing the same message of we did not just launch one device, these are families of devices, so that depending on what type of housekeeping, supervisory function, or secondary MCU applications that you're using, you can utilize that in your design. We also have leveraged TI's strength in the analog peripherals. So in our sensing piece, we have up to 4 mega samples per second 12-bit star ADCs, along with our industry's first zero drift chopper op amps with PGA integrated into the MCU, as well as having comparators, DACs. So really, depending on the level of analog integration that you want, we have different devices, which I'll go into the next slide, kind of through the XY graphic, on how you can pick and choose which MCUs best for you. And then in the control side, specifically for motor control applications, we do have different types of timers, general purpose low power timers, and different DACs as well. And then in the connection piece, we have the standard, UART2C SPI and CAN-SD, which is new for MSP-M0 specifically, as well as security features like the AES functionality. And in terms of just in general with our voltage range, we have voltage from 1.62 to 3.6 volts, up to 1 microamp standby, having a on-chip high frequency oscillator, and in general, enabling a customer to really have that breadth of scalability for all of our different parts. Yeah, and then another just key point for the packages side, we have offered a variety of packages. Some of the smallest packages are, coming from 16 pins and going up to the 64 pins piece of it as well. Okay, so this is kind of giving you the scalability of all of our devices that we have published today online. So you can see here that the main two series of like the 32 megahertz L series MCUs you see in the blue, and then the red 80 megahertz G series as well. And then the yellow is 80 megahertz G series with CAN-FD. So it's the same series, but with integrated CAN-FD. So from here, today, they are live on their product folders. You can request samples, launch pads. The data sheets are available, as well as our software development kit. So again, as the months go on, this is our initial launch. There will be additional devices being added and updated to this view, but just kind of showing the scalability of all our different devices here from 8 kV to 128 kV right now for our two families at the moment. Okay, so kind of touching a little bit more on the packaging side, the scalability that we have right now, 8 pin-to-pin compatible packages, where we really wanted to emphasize that it's 2 times the pins that you are able to have, but half the space. So for example, we have our 16 pins SOT package versus a competitor 8-pin SOIC package that you can utilize more pins for more functionality, but at a low cost. So kind of re-emphasizing our messaging is that we did really work, to create this portfolio where you can have that cost optimization, a safe workspace on the for your designs, as well as increase your functionality too. Okay, so diving into MSPM0L series, which is really what I like to call the entry-level MCUs for simple applications. And there's 2 different families, which is MSPM0L13XX and MSPM0L110X. So the main differences between those is really the analog peripherals, right? So for MSPM0L130X, if you're looking for a transimpedance amplifier, if you're looking for a zero-drift op-amp, if you're looking for a comparator, that's what MSPM0L13X will have. And then MSPM0L110X going up to 32 kilobytes of, 64 kilobytes of flash, is that you do have a general purpose op-amp. You have the general ADC as well, and a temperature sensor, timers, and your IOs as well. So for these types of functions, very like supervisory functions, ADC to wake up time, and things like that that you can utilize the entry-level devices for. And what's a really key point that I wanted to emphasize is that starting at our 1 KU price, it's starting like 39 cents, so low cost for an MCU, as well as having 0.5 microvolts per Celsius for op-amp input offset drift. And we have 46 different OPNs, or orderable part numbers, from 8 kB to 64 kB, which has different package and peripheral options. So yeah, so that is our first family for entry level for MSPM0L devices. And going into a little bit deeper for the getting more accuracy of your sensors, right? We have around 7 times the reduction input for offset voltage error. So as you can see that from the data that we have on the left, kind of comparing the input offset data versus the temperature with no chopping, you can see that the data is kind of all noisy, like, it's not a clean output. But then with input offset versus temperature with chopping, you can see that there's 0 crossover distortion and around less than 150 picoamps of available ultra low input bias current as well. So we really wanted to emphasize that in these different types of sensing applications, you can utilize an integrated zero-drift op-amp in your MCUs, and this is both for MSPM0L and MSPM0G too. Yeah. So for MSPM0G, all these devices in this family operate a speed at 80 megahertz. And this is kind of, again, we have three different families that, or sorry, four different families that we have kind of like you're adding higher peripherals to each of the families, but again, making it simple. So starting from G110X, that is your general purpose M0G device, and then going to 150X, you're adding a little bit more analog, such as your just op amps. We have the math accelerator as well. And moving on to 310X, you have adding more the CAN-FD and G350X as well. So here we have dual 4 bank samples per second, 12-bit ADCs with up to 14-bit oversampling. So depending on your application, you can be able to utilize this functionality, as well as 3 times lower latency in a field-oriented motor control loop. So we've already seen a lot of different applications specifically for motor control, and I'll go a little bit more deeper. But in our software ecosystem, we have motor control designated libraries as well, so it'll be easy to get started to utilize that functionality. And in this case, we do have 87 different OPMs, which are from 32 KB to 128 KB of memory, which package peripheral options. So these are, again, you're going to see devices that include more of our advanced peripherals, such as like the math accelerator, CAN, and LIN, and all of those different functionalities here. Okay, so for the math accelerator piece for MSPM0G, we really wanted to enable fast and efficient math operations at an 80 megahertz M0 plus CPU. So key features here is that we have a 32-bit hardware divider for fixed point and IQ format numbers, as well as divide operations that are up to in 8 cycles. There's square root operations in 21 cycles, 24-bit trigonometric calculations. So as you can see here, again, 3 times lower loop latency in field-oriented motor control applications, 6 times more square root operations per second, and 10 times more divide operations per second as well. So you can see on the graph to the left, we really wanted to show kind of a comparison between 64 megahertz, 80 megahertz, and 80 megahertz M0 plus with our MSP math accelerator, really showing how many math operations per second you can do compared to the other 2 devices. So we wanted to emphasize that this significantly reduces the calculation time of the different operations, increase the computational power for math-intensive and real-time critical tasks, speed up the control loop applications like in motor control FOCs, and lower the power consumption for math calculations as well. So again, re-emphasizing the, you know, you're getting lots of functionality at a low cost, and we have a lot of resources to help, you know, to help support that for your design and your application. All right, so now that we understand the devices, the hardware, what we have launched with MSPM0L and MSPM0G, the next question obviously is, how do we use these, and how do we, you know, use software to actually implement the functionality? So we have 2 different tools that is offered today, which is the graphical configuration tool called SysConfig, or System Configuration Tool, which is really a unique tool where that you can use different peripherals and literally drag and drop and have automatic pin mux resolution that will generate code as an exoskeleton of your code. So for example, if you want to do like a GPIO toggle or some sort of application there, you can literally click and see that, okay, what is my, whatever device that I connected to, what is my code that has been generated. We also have we also have the quick code examples and how-to videos as well that you can take a look at so you can get started pretty easily. Another really unique tool is the Analog Configurator. So based on its name, it's really a tool, again, another graphical tool where you're really dragging and dropping analog blocks to create your design or your front-end analog configuration. So picking a op-amp or picking a ADC. So really it's like you're wiring it, you're testing it, and you're deploying it. And just with a few clicks, you can visualize your signal chain, make modifications, and view real-time data for evaluation. So I think this is a big benefit for those who are not as familiar on how to utilize these types of discrete components within an MCU. And again, we also have really quick videos to watch there as well on how to get started with this tool as well. And diving into our software ecosystem really is seeing both of these diagrams. On the left, you can see that we've kind of created a toolbox, right, of like, this is your application, and here are all the different types of resources that we have for you to utilize. So we have middleware such as automotive, IEC 60730, motor control, TI drivers, non-RTOS and RTOS, different driver libraries, which is optimized for code size and intuitive designs, the TI drivers, which simplifies more abstraction, and optional built-in RTOS management. And then middleware really emphasizes the ease of development of specific applications in different market sectors, such as building factory automation, IEC 60730 self-test library, and appliances. So utilizing this ecosystem is what really is kind of giving those building blocks for you to integrate it into your design. And we also have MSP and Zero Academy, which is really just diving through different specific functionalities of how to use the MCU itself. So, and there's like different like kind of activities that you can utilize so you can really understand how easy it is to use. Is that over 200 code examples on basic functions. And of course, we have our two launch pads available today, which is MSPM0L 1306 and MSPM0G 507, which is basically the two superset variants of our devices that you can do everything on to start evaluating. So also wanted to emphasize our third-party ecosystem as well, where we have different partnerships and tool chains, such as with like Kyle, IAR, and also working with like Seger and Alphatronic, and there's more partnerships in request as well. So yeah, so all of our MSPM0 devices come with access to our entire software ecosystem, which includes the graphical user tools that I showed, which is Sysconfig and Analog Configurator. And you can really just set up and initialize the device very quickly during development. And our optimized software has layers built in it too. So for different variety of application standards and depending on what you're looking for as well. So getting started, today we have many different resources and content available. So we have our MSPM0 overview page that's live on TI.com, where you can just get started with information on product selection table. You can also, there's different application sections such as building automation, medical, appliances, power delivery, factory automation, an introductory to automotive functions as well. And we have, and each product folder actually has many different technical blog contents and white papers, such as mentioned here, like how ARM Cortex-M0+ MCUs are optimized in general purpose processing, sensing, and control. So it's very kind of like a quick how-to on like, if you're thinking about a certain like, oh, I want to create a smoke detector. We have a app brief that walks you through it of how to use the MSPM0 L1343 and implement it into your design. Or if you want to learn how to create a thermometer or a pulse oximeter, we have that as well. We also have some basic demo videos that we did launch at Embedded World as well, which is showing a blood pressure monitor and a pulse oximeter, as well as a chamberless smoke detector configuration too. And so the NSTM Zero overview page is definitely a huge resource that has everything on there. And NSTM Zero SDK has a separate product folder as well that you can request and get started with all the examples and tools that I just mentioned how to use. Then we have NSTM Zero Academy training, which is, as I mentioned, kind of going through different peripherals and functionalities of just very quick, like 5-minute videos on how to use everything. As I mentioned as well, with the applications piece, we have, and we're still working on more applications as well. So if there's anything that you guys are looking for specifically, or you want to know maybe like a dual chip solution and things like that, we are definitely working with other TI product lines, as well as integrating these new applications for NSTM Zero specifically to have that available. Then we have the NSTM Zero production product selection tool, which really is helpful because, of course, like, as I mentioned, these are not just 1 or 2 devices. This is a whole family of devices. So it's really helpful to kind of getting to pick and choose which parts will make sense and that is best for your design. And then we do have our development tool kit, which is NSTM Zero L1306, which you can have available to request today. So if there's, I guess, the main message that I want to present to everyone today is that we are definitely super excited to launch this whole new family. And as I mentioned, it's just kind of the beginning. And the main takeaways are that it's low cost, scalable, and simple to use. And we are working on creating more collateral and just ease of use type resources that everyone can use. And we're looking forward to your feedback and wanting to know what else you are looking for as well. So with that being said, you can get more information on tia.com/NSTM0 and visit the tia.com/new product update webinar page to listen to this recording again, and feel free to ask me any questions.